one more ice table with the same reaction as the last one. It's this hydrogen plus fluorine forming hydrogen fluoride, H2 plus F2, in equilibrium with 2 hydrogen fluorides. There's one thing a little bit different about this problem than the last one, and I'll at least expose you to this. We've got the same reaction. We've got 3 moles of hydrogen, 6 moles of fluorine in a 3-liter flask. Okay, so we're going to ice this as if it were a verb, right? ICE. Initial needs to be moles per liter, concentration, or pressure. So we're going to take that 3 moles of hydrogen and divide by the 3-liter flask and say 1 mole per liter. And then the fluorine will be 6 divided by 3 for 2 moles per liter. Let's see, what else do we have? We still have the equilibrium constant. K is the same, about 115. We want the equilibrium concentrations of all species. And that's it. They don't give you any other data. So since they never mention the hydrogen fluoride, I'm going to assume that's 0. Initially, maybe there is no hydrogen fluoride. That's always a safe assumption. If they don't mention it, plug it in as a 0. Which then saves us the Q calculation. If we see a 0 in our initial data, we know we have to shift in that direction. You can't have any zeros at equilibrium. If this is going forward and reverse, there's got to be some of everything present. So we have to shift forward because of this 0. Shift forward. And again, we don't know by how much, but we can plug it in as x. So these will go down by x minus x. This will go up by 2x. All right? So then at equilibrium, we'll have 1 minus x, 2 minus x, and this will just be 2x. All right, so far you're cruising along. You're like, man, I think I'm getting this super easy. We just got to solve for x and we're done, right? Right. All right, so here's what I don't like about this one. Solving for x is actually kind of a pain in the patootie. Let's set it up. Let's see what we got. The same k value. K is 115. We'll set up the expression products 2x. But we got to square it again because of the ratio in the balanced equation over reactants. 1 minus x to the first, 2 minus x to the first. Do you see why I don't like this one as much anymore? I mean, it's not that it's impossible, but it's just a little bit of a pain. In the last couple examples, we got something that we could easily take the square root of both sides, and then that big time simplified our algebra. We can't do that here. We don't have the same thing on the top and the bottom. I could take the square root of the top, but I can't on the bottom. So we have no choice but to do lots of algebra. We're going to have to FOIL this thing, aren't we? Okay, so let's simplify this bottom, the denominator, and say 2 minus 3x plus x squared. All right, and then I'm going to cross multiply. Gosh, this is a pain, isn't it? Okay, let's cross multiply and see what we get. So 115 times 2 would give me, yuck, 230. Ick. Minus times 3. How about 345x plus, icky, 115x squared equals 4x squared. Okay, so let's simplify that a little bit and say 230 minus 345x plus 111x squared equals 0. Awesome. Okay, so I'm going to cheat at this point, and I'm going to plug this into my calculator. I'm going to use that quadratic solver, which if you don't have that on your calculator, don't freak out. Because here's where I'll tell you that they will not give you one like this on the AP test. On the AP test, you do not need a programmable calculator. You need a scientific calculator. You need to be able to do logs and all kinds of fun stuff like that. But you do not need to have a program that will solve the quadratic. They will not give you a problem like this. Now, it's kind of fun to walk through it. Like, we can solve this. I mean, I would be aware that this could happen. But now you're probably like, oh, well, shut it off. Or, if I'm not going to have to do this on the AP test, close this one. I'm not watching the end of this video. Unless you're really curious what x comes out to be. Maybe you're like trying to solve x in your head right now. If you are, that's kind of nerdy. But really, they will not give you one like this on the AP test. You will be able to simplify them, and you will not need a quadratic solver when you do the AP test. But we can do this. So I'm going to plug this in, ABC, into my little quadratic solver. And I'm going to get this. X equals 2.14 or 0.968. Well, why do we pick one? Oh, well, can you see which one has to be right? If I look at my initials, I only have 1 mole of hydrogen per liter. I can't take 1 minus 2.14. Like, I can't make x greater than 1. Like, I can't react more than what I originally had. So between these two, it can't be 2.14. It's got to be this guy. That now I can plug in, and I can solve for the concentrations at equilibrium. So at equilibrium, my hydrogen will be small, 0.032 moles per liter. My fluorine, F2, is 2 minus, so 1.032 moles per liter. And my hydrogen fluoride is 2x. All right, so 1.936 moles per liter. There they are. So again, just something to be aware of. Maybe this is kind of just a good one to practice. Make sure that you had your ice table set up right. Make sure we had the equilibrium expression set up right. I mean, they could have you do something like this, even a multiple choice question, and say something like, what would be the correct equilibrium expression? And then maybe the answer would be something that looks like this. We're like, I don't actually have to solve for x. They might just want to know, like, what would be the correct expression? Well, I could do that without actually having to plug it in my calculator. So, I mean, this problem isn't all for a loss. It's a good problem, but just be aware that you do not need to solve quadratics on the AP test. Although maybe that makes you sad. And maybe some of us, we already shut this one up.